The key to this question is to read this interesting graph carefully, and like so many things, reading the directions is key. Here, reading the legend to the graph is key. The width of each bar indicates potential abatement measured in gigatons of CO2, gigatons, I should say, while the height indicates the cost of abatement per ton. So let's just go through and see what we can see about each of these statements. Nuclear energy has a higher potential to abate emissions than reforestation of degraded forests. So remember that the x-axis is the potential to abate. That's the width of each bar indicates potential abatement measured in gigatons. So notice this the width of the nuclear bar is really wide, where reforestation is, degraded land reforestation is here. Lower abatement cost per ton, but much smaller potential abatement. So nuclear energy has a higher potential to abate emissions than reforestation. That's actually true. So let's mark that as true. Well, I'll keep going. I didn't remember this was A, but A is true. If I find a second one that's true, this was a bad question. Let's keep going. Solar energy produces more abatement per euro spent than nuclear power. So this would be a lower euro per abatement than you can express this abatement cost and the cost effectiveness. A lower euro per ton of CO2 emissions is more efficient, but you could also say that a higher ton of CO2 emissions per euro is better. Either way, the lower on this, the better, right? The reciprocal of this would be higher than the reciprocal of that. So solar energy produces more abatement per euro spent than nuclear power. No, we see solar is up here, both of these bar, and that's higher euro per ton of CO2 abated than nuclear. That means if the euros per ton is lower for nuclear, that means the abatement per euro, the reciprocal of that, is higher for nuclear power, not for solar. So we can rule that one out. That was a little tricky, right? It was the reciprocal of what's on the y-axis rather than what's on the y-axis itself. All right, let's go back to see what we see about C. Geothermal technology has a very low abatement potential and therefore should never be adopted. Let's see, where's geothermal? Here it is. Notice that, there's not a huge potential to abate CO2 by moving to geothermal, but notice that the costs of abatement by moving to geothermal are really low. So quite the contrary, we should take up every chance there is to move to geothermal. Just there's not enough to make a big dent in the problem, is all the graph is telling us. So this is false. And then finally, solar energy. Now I've lost my. I can't read because my controls for the video are blocking me. Solar energy should be preferred to nuclear power in the abatement of greenhouse gas emissions. And here again, no. What the whole point of this analysis, we want to identify the low cost abatement opportunities, take advantage of them. We do that first. Only if we're really abating a lot would we move to these higher marginal cost of abatement options. So here, solar energy preferred to nuclear power. No, solar is higher, is more expensive. Nuclear less expensive. So nuclear energy would be preferred on a cost per ton abated. And the statement is false. It may be the case, though this graph doesn't tell us, it may be the case that the other things besides CO2 abatement capacity and cost of abatement, other factors such as the safety of nuclear waste disposal might lead us against nuclear. But in terms of what we know from this graph, we can't say that solar should be preferred. So that's false. It has to be true to be true. If there's some ambiguity, we can't conclude that the statement is true. We have to rule it false, especially when we have that option A that's unambiguously true. All right, or unambiguously correct in the language of this problem.